This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
Okay, this lecture's on decision trees and it relates to expected values. We've been through expected values. The only problem is that if there are several decisions that need making, it can all get very confusing and you lose track of what's going on. And as you'll see as we look through an example, the purpose of a decision tree, it's just a little diagram, making sure we've sorted out all the decisions that need making. And once we're clear what's happening, we'll be back to the pure expected value approach. Now, I can't really explain what I mean by an example. So if you turn to the example, Combi are having problems with one of their offices. We'll have a quick read through in a moment. But I'll say in advance, this example is as big as you could ever see. You'll never be asked to do one this big in the exam. But it's better doing one too hard than too easy. If you can sort out with me what's happening here and how we're using decision trees, then you should have no problem coping with anything that could be asked in the exam. So let's have a quick read through. We'll read in detail, obviously, as we actually come to go through it and solve it. Combi are having problems with one of their offices and have decided there are 3 courses of action available to them. We can either shut down the office, we'll get 5 million, or we can refurbish the office, expensive one, paying 4 million, or we can have a cheap refurbishment, 2 million. So 3 courses of action. Ultimately, we're going to have to decide which is the better of the 3 choices. If they do the expensive refurbishment, then a good result will yield a return of 13.5 million. A poor result will only yield 6.5 million. So if you think back to what we did in previous lectures, there's some uncertainty there. If we do expensive, then it may be high return, it may be low. And similarly, if we do the cheaper refurbishment, good result yields 8.5 million, poor result yields 4 million. In either case, the probability of the refurbishment achieving a good result has been estimated to be 2/3. So I hope it's making sense so far. 3 courses of action available. The outcome is uncertain. We know the potential returns, we know the probabilities. However, to make it a bit more complicated, an independent company has offered to undertake market research for them in order to identify in advance whether the result of the refurbishment is likely to be good or poor. So in fact, there's a 4th option here. Instead of immediately shut down, refurbish, expensive or cheap, we could instead do market research. And only when we know from the market research whether it's likely to be good or not, then decide whether to shut down, expensive or cheap. It's getting more complicated. This is why in a minute drawing a diagram will help us make sure we've covered everything. Unfortunately, the research cannot be guaranteed to be accurate. However, if the research tells us it'll be a good result, there's a 9, where are we? I've missed a line. The market research, it'll cost us 200,000. There's a 68% probability it will indicate a good result. But this research cannot guarantee to be accurate. But if it does say there'll be a good result, the probability the result really will be good is 91%. If it indicates a poor result, probability of it being good is 13%. We've already decided that if we do have market research and it indicates a poor result, we'll only be prepared to consider cheaper. Now, you're probably getting completely lost by then, so let's make a start and slowly go through it. What choices do we have from day 1? From day 1, and I'll explain my symbols in a second, it turns out we've actually got 4 choices. We could either immediately shut down. Oh, and incidentally, I must say that because I'm going to write quite a bit on the screen, I'm going to have to keep it fairly small. So I hope you'll be able to follow me. I'll try and be as neat as I can. But there is obviously an answer at the back. So there's one course of action we may take, as of today, shut down. Alternatively, we may decide on an expensive refurbishment. We may decide on a cheap refurbishment. So those were the first three choices available. Or we found out at the end, instead, we could do market research and decide later. Now, what have I done there? That's what I mean by a diagram, and you can see why it's called a tree. Well, perhaps not, but if you lie on your side, it looks like branches of a tree. But that box that I've drawn is to show it's a decision point. It's obviously going to be our decision which of those four things to do first. We don't know which yet, we'll worry about that later. But it's going to be our choice which of those four to do as of now. And the lines, we're using the lines obviously to show the various choices. Let's carry on though. If we shut, that's obviously end of story. I'll worry about the amounts and so on later. At the moment, I want to show what the choices are. But if we shut, finished. On the other hand, if we do decide to do the expensive refurbishment, there are two possible outcomes. If you look just below the ABC, if we do expensive, it seems to either be a good result or a poor result. Now, that's not our choice. That's what's uncertain. But do expensive, and either there'll be a good result or there'll be a poor result. Now, again, I'll worry about the costings later, but all for the moment I'm trying to do is look at the various possible outcomes. Now there, you see, if you do expensive, either it ends up being good or it ends up being poor, but that isn't our decision, that's uncertainty. So I'm using that blob to show where it's uncertain. Whenever I use a square, it's a decision we're going to have to make. When I use a blob, that's just uncertain. But that would be the end of that. If we do expensive, it's either good, finished, or it's poor, finished. What if we do a cheap refurbishment? Well, again, if we do cheap, we then sit and wait, and one of two things happen. Either it turns out to be good, or it turns out to be poor. So I hope so far, so good. What about market research, though? If we choose market research, we'll pay them the money, but then we have to wait and see what they tell us. They will tell us that they think it's going to be good or that they think it's going to be bad. Because we don't know, that's uncertain. So, if we do market research, we wait, and they either say it's good, told good, or they come back and we're told poor. So again, I hope you agree, it's uncertain. It says somewhere the probability that it'll tell us it's a good result is 68%. We'll worry about the costings and whatever later. But this time we won't stop there. Because if they tell us it's going to be good, remember they might be wrong, but in the knowledge that they've told us it's going to be good, then we'll have to make a decision. Because now we know it's going to be good, we still have the choice, as before. We could immediately decide to shut, or we could decide to do the expensive refurbishment, or we could decide to do the cheap refurbishment. And here you can see it's starting to get a bit of a big diagram. So appreciate where we are. Just suppose we end up deciding to do market research. Suppose they tell us it's good. Then we'll have to decide, maybe we'll shut and that's the end of it. Or maybe we choose to do the expensive refurbishment. But of course, even though they've told us it's good, they're not certain. So it may end up with a good result. It may end up with a poor result. And similarly, even though market research may have told us it's a good result, we'll still be able, if we want, to choose a cheap refurbishment. And again, if we choose a cheap, there's either going to be a good result or a poor result. And of course, in for each of those, that would then be the end of it. Finally, though, suppose we do market research and they tell us it's a bad result. Well, what does the question say? It says we've already, the very last paragraph or sentence, CIMA have already decided that if they do have market research and if the research indicates a poor result, then we're only prepared to consider the cheaper refurbishment. And so, if this happens, oops, if we've done the research, if they tell us it's poor, we've already decided we're not going to do the expensive refurbishment, but we still will have to decide, surely. We'll still have the choice, so a box. We're going to still be able to shut. And that's the end of it. Or we could do the cheap refurbishment. Now, of course, if we decided to shut, that's the end. But finally, if we do the cheap refurbishment, then even though market research thinks the result will be poor, the result could be good result. It could be wrong. Or more likely, of course, it could still be a poor result. Oh. And so, I warned you in advance, it's going to be a bit messy, and this is as hard a question as you could ever see. But I hope at least the purpose of this tree, the logic of the tree is making sense. That had it just been, oh, there are two choices and two possible outcomes, we wouldn't have needed to draw a picture. You know, think about examples we've done in earlier lectures. But here, there's so much going on that having a diagram in front of us makes it much clearer now when we come to actually look at the costs and returns involved and actually start making the decisions. So I hope that's clear. And again, symbols, the box, people use different symbols, but the symbols I'm using, the box is showing that it's our choice. We'll decide which of those first four to do, but the later decisions may be depending. The blob is showing that the result is uncertain. Could be good, could be poor, and so on. Okay. Obviously, we want to end up solving it and making the decision. So let's now start going back and looking at the amounts and the probabilities. Let's fill them in, and then we'll be in a position to make the decision. So let's go through them all in turn. I'll do a branch at a time. First of all, suppose our decision does end up being to shut. Well, note A says if we shut down the office, will receive 5 million. So we now know the benefit of making that decision. And what happens if we decide to do the expensive refurbishment? Well, first of all, whatever happens, we'll have to pay out 4 million. I'll stop putting the dollar sign, I haven't much room. And then one of two things will happen. Either, if you jump down below C, if we do it, a good result will give us 13.5 million. So we'd have been paying out 4, then we'll get back 13.5, a net 9.5 million. Or if we do poor, we'll still have paid out 4 million and we'll get back 6.5 million. So if you prefer a net 2.5 million. If we do cheap refurbishment, no, C says we'll pay out, whatever happens, 2 million. And what do we get back? If it's good, we get back 8.5 million. If it's poor, we get back 4 million. Let's carry on with the last of the choices, market research. If we choose to do market research, 4 paragraphs from the end, it'll cost 200,000, so we'll have to pay out, whatever happens, 0.2 million. Then we wait to hear what they say. Well, if they tell us it's good, we might decide to shut. And remember, shut gives us 5 million, so we'll have paid out 0.2, but we then get back 5. Or we do expensive, and again, expensive would mean paying out 4 million, another 4 million. And if it gives a good result, we get back 13.5. If it gives a poor result, 6.5. If we've done market research, all right, we paid 0.2 million. But if we then decide to do the cheap refurbishment, we'll pay out 2 million. And we get back 8.5 million or 4 million. So now we know all the various things that can happen there. Finally, though, suppose we do market research. Again, we've paid out 0.2 million. Suppose they tell us it's a poor result. Then again, we either shut and get back 5 million, or it said we're not going to consider the expensive refurbishment, we'll do the cheap one, pay out another 2 million. Good result gives us 8.5 million. Poor result, 4 million. So I hope that's clear. I've put all the amounts in. Do note, please, because there is some people do it a tiny bit differently, but it gives the same end results. I'm showing each flow separately. So if you go back to expensive refurbishment, I'm saying you'll pay 4, and then either you'll get back 13.5, which means a net. We end up with a net 9.5 million. Or you pay out 4 and get back 6.5, a net 2.5 million. So some people prefer, instead of showing each bit separately, simply to show the net result, 9.5, 2.5. I'll change it back to what I had in a minute. If you prefer to do that, fine. You'll see later you'd end up with exactly the same result as I'm going to end up with. I just prefer to look at the flows separately. So let me put them back in. We'll pay out 4. Then we get back either 13.5 and 6.5. So I hope we're all there so far. We've drawn the diagram showing all the various things that can happen. And we've now put done the costings in the sense that we know, depending on what we do and what happens later, we know where we'll be spending and what we'll be receiving. To finish setting it up, let's now put in the probabilities, because whenever there's uncertainty, well, as always, we've got these probabilities. It might be this, it might be that. And so I'll put this in a different colour to try and hopefully make it clear. Back down the tree again. Shutting irrelevant, no probability involved, but expensive refurbishment, maybe good, maybe poor. Where are we? Halfway down the question. In either case, the probability of the refurbishment achieving a good result has been estimated to be 2/3. So there's a 2/3 probability it'll be good, and surely therefore a 1/3 probability it'll be poor. It says that'll be the case in either case, whether we do expensive or cheap. So if we do cheap, 2/3 probability it's good, a 1/3 probability it's poor. What about if we do market research? Market research, remember, we have to wait until we hear what they say, good or poor, and then we'll make the decision. So what's the probability they tell us it'll be good? 4 or 5 paragraphs from the end. Independent companies offer to undertake market research. Boom, boom, boom. The research will cost 200. There's a 68% probability it'll be good. They'll tell us it's good, sorry. So 68% probability they say it's good. And therefore, surely 100 minus 68, 32% probability. The answer will be that it's going to be bad. But we're not finished it yet. Suppose they tell us it's good. They tell us it's good, but here it says it cannot be guaranteed to be accurate. So if we do carry on and decide to refurbish, the actual result, they may have been correct and it says good. They may be wrong and it says poor. Well, it says if the research indicates a good result, then the probability of the actual result being good is 91%. So they've said it's good. There's a 91% chance that it actually is good, and therefore a 9% chance that it actually turns out to be poor. And that'll be the same for either of them. So even if it's cheap, 91%, 9%. Or if you prefer, incidentally, 91% is 0.91 probability, 9% 0.09 probability. Doesn't matter when we come to do the arithmetic. I'll make it clear. And last of all for this bit, suppose the research says it's going to be a poor result. Well, again, it's not guaranteed that they're right, but it says if it indicates a poor result, the probability that it actually turns out to be good is 13%. So it turned out we were only going to consider cheap refurbishment, but there's a 13% chance they were wrong, and the result is actually good. But of course, more likely, 87% chance that they were right, 100 minus 13, and it's a poor result. So there we are, we've drawn the tree. I've now put in all the cash flows. I've put in the probabilities. We're now in a position to start making the decision. And let's look at these various options. You know, our main decision as of now is, shall I shut or shall I refurbish or market research? Well, shutting, we know what the outcome is. It's 5 million. The question is whether the other three give us more or less than 5 million. Well, expensive research, of course, we've got the uncertainty. We pay out 4, we might get back 13.5, we might get back 6.5. And so, in the normal way, whenever there's uncertainty, we'll replace the uncertainty with the expected value. and I'll label the points. What colour shall I use? Green. So at point 1, remember at point 1, we've paid out 4 million. But what will we get? I'll show my workings. We'll either get 13.5 million, or we'll get 6.5 million. We know the probabilities. There's a 2/3 probability of getting 13.5, a third probability of getting 6.5. And so we'll remove the uncertainty, we'll replace it with the expected value. So as always, multiply by the probabilities and add up. So 13.5 times 2/3 is 9. 6.5 times a third is 2.17. 11.17. And so I'm now going to say that if we do expensive, we will pay out 4 million, but we'll get an expected 11.17 million. So I can now forget the 13.5, the 6.5. Effectively, my choice so far is either shut and get 5 million, or do expensive, which gives us 11.17 minus 4 million. It will give us 7.17 million. But the uncertain bit I can now forget. I've replaced it with the expected value. In a similar way, what about here? Another option was cheap refurbishment. We only needed to pay out 2 million, but we're then uncertain. So we either get back 8.5 million or 4 million. The probabilities again, 2/3, 1/3. And so the expected return, if we do the cheap, 8.5 times 2/3 is 5.67. Let me check that, 8.5 times 2/3. Yeah, 5.67, or 4 times a third, 1.33. An expected 7. So it's the non-expected value calculations. I'm not going to repeat all the logic of that again. But it does mean that if we choose cheap, we will pay out 2, and we'll get back an expected 7. So a net 5 million, 7 minus 2. What about the next one though? Market research. Okay, at 0.2 million, we know 68% chance it'll good, 32% will be poor, but I can't do what I've just done until I know what the return will be from good and poor, and I don't know what the return will be until I know what I would decide. You see, if you're doing market research and we're told it's good, well, the return we get depends on whether I'm going to decide to shut expensive or cheap. And so before I can look at how the benefit of market research option, I have to decide what I would do if that happened. If we did research and if we were told it was good, what would I decide to do? And so let's look at that a little bit on its own. We'll either decide to shut and we get 5 million, or, let me change the number, if it's expensive, we'll pay out 4 million, and how much do we get? Well, we either get 13.5 or we get 6.5. The probabilities are 0.91, 0.09. So multiplying 12.29, not really about a bit of rounding, 0.5, 8, 12.87. So the benefit of expensive would be 12.87. Or if we decide to do cheap, We'll pay out 2 million, another 2 million, but we'll get back either 8.5 or 4. Again, probabilities 0.91, 91%, or 9%, 0.09. Gives us 7.74 or 0.36, or around 0.36, sorry. 8.1. Now, why am I doing this? Because I need to know what choice we make if we do market research and if we're told it's good. Well, now I can decide. If I label this A, box A, what is my choice? Box A, with the choice, we either shut and we get 5 million. You know, we've paid 0.2 million for the research, whatever happens. But having paid that, we shut and get 5 million, or we do the expensive, we'll get 12.87 million, but we'll have had to pay 4 million, so a net 8.87 million. Or we do the cheap. And if we do the cheap, we'll get back an expected 8.1 million. We'll have had to pay 2 million. And so we get 6.1. Now it's our choice. And so which would we choose if we ever got to that situation? We do market research, we say it's good. Well, obviously, we'll choose the highest. We'll choose to do expensive research. I'll mark it with a hatched line so I don't forget. And therefore, we know that the benefit of market research, if they tell us it's good, we know we'll end up with 8.87 million. Similarly, though, what about if they tell us it's poor? If they tell us it's poor, we then have to make a decision. We either shut and get 5 million, or, what number am I up to? Number 5. We did the alternative, do the cheap refurbishment and either get good result, poor result. So 0.5. Good result, 8.5 million. Poor result, 4 million. Probabilities, 0.13, 13%. 0.87, 87%. 1.11. 3.48. So 4.59. Oops. And so, what decision would I make at point B, where it's our choice? At B, well, I think I hardly need write down, surely. I'm not going to write down. It's our choice. We either shut and get 5 million, or we do a cheap refurbishment. We pay out 2 million to get back 4.59 million, a net 2.59. I think fairly obviously we would choose to shut. And therefore, if we do market research, if they tell us it's poor, we know what the return would be because we'd shut. We know we'll get 5 million. All right, now we're almost there, because if you go back to market research, if we decide we pay out 0.2 million, but there's uncertainty, they'll tell us one of two things, but we now know what each of those two results are worth. So we know at 0.6, we know if we do market research, I'm running out of space still. If we do market research, we either get, where are we? This is I've lost it 6. They either tell us it's good and we get 8.87, or they tell us it's poor and we'd be shutting, so we get 5. And the probabilities, they tell us it's good is 0.68, they tell us it's bad is 0.32. And so the expected benefit of doing the market research, 6.03, 1.6 is 7.63. So 0.6, 7.63. And all the later bits we can, for the moment, forget. We know if we do the market research, pay out 0.2 million. But because of the later decision that he's making, we do know that the benefit of doing market research will get back 7.63. Now, finally, we can go back to our first decision. Where I'm at to with labelling, I'll call it C. C. Now I can decide which of the 4 things to do now. Let's list them and make sure. One option is to shut immediately, so this is C. And if we shut, we get 5 million. Or the second option was to do the expensive refurbishment. Expensive refurbishment, we pay out 4 and get back an expected 11.17. And so a net 7.17. Or we do the cheap refurbishment. The cheap refurbishment, we pay out 2 and get back 7. A net 5 million. Or finally, we do market research. And market research, we pay out 0.2 and get back 7.63. It's our choice, and we'll pick whichever is the best of those 4. The best is in fact to do the market research, 7.43. And so there we are. Although strictly the full answer is this: we will do the market research, I hope you're clear why. But remember, because we're doing market research, there is another decision will have to be made later, depending on what they tell us. And so the full answer, we should really write that down. And they give us 2 answers. So if we're told good, then what would be the decision? We carry on and do the expensive refurbishment. Or, if told poor, what will we do? If they told us poor, we decide to shut. So there's the full answer. The decision we make now, together with any future decisions. Now, I warned you in advance, this was a very messy one, but deliberately, because it's got everything in. And if we can sort that out, if you're happy with what I've done, then you can deal with anything. And just note, it doesn't affect the answer at all, but as I've written below the example, this market research here is an example of imperfect knowledge. Perfect knowledge is when you have something like market research, and if they say it's good, it definitely will be good. If it's bad, it'll definitely be bad. Where the information you're getting is perfect. Imperfect knowledge is what's happened here. So they tell us it's good. It does mean it's much more likely to be good, but it's not perfect. They could be wrong, which of course is more realistic in real life. Okay, there we are.